So let's talk about the most famous comet of all, Halley's Comet. Very interesting history behind this. Edmund Halley, as I think it's pronounced in England, Edmund Halley was studying comets. And as you may remember from chapter 2, way back, he needed a little help with the physics of how this worked. And he turned to kind of an eccentric guy named Isaac Newton. And when he discovered all of that, not only had Newton figured out the orbit of comets, but he figured out so many things, he convinced Newton to publish his book, Principia, actually paid for it himself to be published. So anyway, but using Newton's work, Halley was able to predict the return of a comet that he had seen. Unfortunately, he didn't live to see the comet itself return, but he had calculated it would have a 76-year period, and that's one reason it's so famous. First, because it was the first true comet that we really knew what it was. We knew it was going to come back around the sun and orbit just like a planet. And secondly, it matches up well with the human lifetime. You sort of have a once-in-a-lifetime chance to see Halley's Comet, which is another reason it's famous. So the 1682 comet was the one he had seen personally, predicted it would come back in 1758. Now, something kind of interesting happened there. Let me just mention this. He was off by a little bit. He'd predicted, let's say, it was going to come back in September of 1758, and September came and went, no comet. October, November. By December, people were actually starting to worry, like, hey, what's the deal? Maybe this guy was actually wrong. And on Christmas Day, 1758, a farmer, we say, recovered the comet and was the first to see it. And it's interesting why he was off by a little bit, not his fault. We'll get to that in a minute. But once they knew that this same thing just keeps going around the sun, they were able to trace it back continuously. We know every 76 years that it's come around since 240 BC, and then sporadically before that. Some interesting times that it's passed by. 1910 was particularly close. It was so close people were worried about it, because Earth technically passed through the tail of the comet in 1910. Some unscrupulous people were trying to sell anti-comet pills to protect you, which is kind of silly. Now, this is one of the more random things in my notes. Mark Twain. What in the world does Mark Twain have to do with Halley's Comet? Well, it turns out that Mark Twain was born in a Halley's Comet year in the 1800s. And so when the 1910 comet was coming around, he was, the second or third most famous person in America at that point. And newspapers came to Twain and said, hey, what do you think about your comet coming back? And he said in the paper, I came in with Halley's Comet and I expect to go out with it. And he did. He actually died within days of Halley's Comet returning, which is weird. Mark Twain actually predicted his own death, which is quite interesting. Anyway, and then another famous sighting was in 1066. As you, of course, remember from your world history, that was the year that William the Conqueror invaded England, changed the course of England forever. That was in 1066. And in the day, instead of sending stuff out on Twitter, you made tapestries to record such big events. And so they made this famous one called the Bayeux Tapestry, which I'll show you right here. And in that tapestry, now here's King Harold I sitting on the throne. He was the one who was deposed during this takeover by William the Conqueror. And there in the corner of the tapestry was Halley's Comet in the sky. So it's showing this omen that Halley's Comet clearly showed that King Harold was doomed, right? Except that that's a lie. Yeah, Halley's Comet actually didn't come through until later that year after King Harold was off the throne. So they sort of revised history on this tapestry. Same year, but not same time. They revised it to make the story, the narrative fit better. All right. So the 1986 passing was the first time in human history that we had the ability to go see it up close with spacecraft. So the Soviets went, even the Italian Space Agency went, and NASA did not. Yeah, we blew it. We didn't go in 86 when we had the chance. It was a terrible year of the Space Shuttle Challenger disaster. And Just bad in terms of NASA. For NASA, bad year. But anyway, the Soviets got some great pictures, as did the Italian spaceship Giotto. Now, why Giotto? Giotto was an artist in the Renaissance. We'll get to that in just a minute, why they would name a spacecraft after him. But anyway, the Giotto spacecraft was able to take up-close pictures and see this very dark, dirty snowball, if you will, potato-shaped, and so forth, exactly like we'd expect. But here was the big discovery. You had jets shooting out from it. From the side that was facing the sun, the dry ice was sublimating and shooting out jets, which makes the nucleus spin, and it throws it off course. Meaning, that's why Edmund Halley was off a little bit in his calculation. Comets aren't simple things like asteroids. If you use high school physics on an asteroid, you're going to very accurately predict when it comes back. But comets aren't that simple. They have their own built-in jet engines that change the dynamics. So, not his fault. Here it is. Well, actually, this is a different one, different comet, but you can see the jets shooting out there. And that's going to change, of course, its trajectory. Pretty cool stuff. Oh, back to Giotto for a moment. Here's one of Giotto's famous paintings. Giotto actually studied under the same, he was an apprentice at the same time as a guy named Leonardo da Vinci. But anyway, here's Giotto's painting of the manger scene of the birth of Jesus. And as you know, probably from that there was the star in the east when Jesus was born that told people how to go there and witness this event, the three wise men and so forth. But anyway, astronomers actually debate what could have been in the sky at that time. Sometimes they think it was some kind of conjunction of Venus and Jupiter that would have been super bright. But anyway, guess what Giotto chose? Right up there above the manger, yep, Halley's Comet. That's definitely not the case, by the way. Historically, those two events, the birth of Jesus and Halley's Comet, there's no way that was a Halley's Comet year. So Giotto was a little off on that part. All right. One of the great events since I've been an adult in astronomy was something called Shoemaker Levy 9, discovered by Gene and Carolyn Shoemaker and David Levy. It's a great story, actually, how they discovered it. They weren't going to shoot that night. It was a little bit cloudy, and they were using film. And Carolyn Shoemaker really insisted. She found some old film and said, what if we use this? It may not even be any good. And, of course, they ended up making their greatest discovery that night, because when she developed the film, she noticed this weird smear on the film. And they sat around talking about it and finally decided it was a comet that had broken up into pieces. It turns out there are 9 major pieces, hence the name Shoemaker Levy 9. So they realized that the gravity of Jupiter had split this nucleus up into these pieces. And then, even better, they found out that it was just going to sort of slingshot around Jupiter and come right back into Jupiter in July of 1994. So in advance, we knew that a comet was going to hit Jupiter. And I'd have to say that in my lifetime, this is the one time you could say for sure that every telescope on Earth was pointed at the same thing, because everybody wanted to see if we would see the effects of Jupiter getting hit. And it was pretty amazing when we finally got the pictures from the largest telescopes. They did see it. This created fireballs the size of planet Earth. And it was a scary thing, because you realized, hey, there are things flying around out there, and if one of these had hit the Earth, we'd be done. I don't think it's just a coincidence that this happened in 94, and just about 3 or 4 years later, you had 2 major motion pictures out, Deep Impact and Armageddon, about Earth getting hit. So it made us very cognizant, very aware of that possibility. So what did it do to Jupiter? Getting hit with 1 billion nuclear bombs? Practically nothing. I mean, it's amazing. It kind of got a black eye for a few days. That was it. We saw a few dark spots for a few days, which is incredible in itself. So let's just take a look. They called this the string of pearls, the way it had broken up. That's from the Hubble telescope. And then right here on the left, you see that? You think, oh, that's it? Yeah, that, again, remember, Jupiter is 11 times wider than the Earth. So that is a fireball the size of planet Earth there. And what was left afterwards? Look at this. Yeah, just a dark spot, a few dark spots. And they weren't even there for long. Just absolutely amazing. Really neat event. Now, check this out. You think, well, that was quite a while ago. Well, check this out. 2009, it happened again. Except this time, nobody saw it coming. And it was an amateur astronomer that first noticed that there was a big new mark on Jupiter. I love that aspect of this. There was an amateur, scooped everybody and saw this big mark, and we knew then that Jupiter had been hit. So that does happen. Okay, so which is better, Earth getting hit by an asteroid or a comet? Comets are not very big and not very massive. So you'd think that might be better. Better to get hit by a snowball, in other words, than get hit by a rock, right? But then you throw in the fact that comets on average are traveling about 3 times faster than asteroids. An asteroid would hit us, let's say, roughly 20,000 miles per hour. A comet at 60,000 miles per hour, and that changes the dynamic. Either one of them is really bad news for the Earth. Comets disintegrate over time. Later we'll learn that's how meteor showers are actually created. Comets disintegrate over time, so poor Halley's Comet has a limited number. It has about 5,000 orbits left, so it's good for another 40,000 years, roughly. Look how, this is the lowest density thing we've ever talked about. The nucleus of a comet, and that's the densest part of it, is only 100 kilograms per cubic meter. These fluffy, dirty snowballs. Not a whole lot to them, but they do have organics. It's probably why they're dark. You have methane, you see there, and ammonia, and dry ice, of course. Anyway, so they're very interesting to scientists to help study again, because they're primitive. They haven't changed. It kind of gives us an idea of what the early solar system was like. Here you see a comparison of some asteroids with comets down at the bottom right. I'm afraid I'm kind of blocking that a little bit here for you, but you can see that's Halley's Comet right there, that little peanut-shaped nucleus, compared to some. There's Matilde, that was in the notes earlier. There's Eros, the one we orbited, and you can see they're quite a bit larger than the typical dirty snowball down here, but these things are coming in faster. All right, one of my favorite missions. This was kind of funny in a way, where life was imitating art, where we actually had a mission called Deep Impact, which was sort of named after the movie Deep Impact, which of course was sort of written because of a real impact on Jupiter. But anyway, so it was life imitating art, imitating life. So look at this. We sent about a 600-pound ball of copper smack into an asteroid. Just the fact we could pull that off is pretty amazing. And our goal was to shoot out material and then study that material with the spectroscope, which is what that gold tube is right there, and see what it's made of. Deep Impact mission, one of my favorites. Look at this. Here's what they wanted it to do, and bam, there's an actual picture of the explosion at that point. Just amazing stuff. More amazing was Stardust mission. It went to a brand new comet. Brand new in the sense it was the first time it had orbited close to our sun. It had been kicked in close to the sun, so it was a nice pristine shape. There it is. That's actually the ship returning. Yes, it returned to Earth with samples from the comet. Pretty amazing that they pulled that off. Now, how do you pick up comet pieces? There's the ship after it landed back on the Earth. I'm going to play just a bit of this, actually.
Stardust is out to answer very, very key questions about the formation of the solar system and the formation of Earth. It's believed that comets have brought the water to Earth and a lot of the chemical building blocks that we're comprised of.
3, 2, we have main engine start, 0, and liftoff of the
It launched in 1999. 2 years later, in 2001, it flew by the Earth. And as we flew by the Earth, we had used the tug of the Earth's gravity to throw us further out into the solar system. That allowed us to go out to the orbit of the comet Bill 2. So the comet counter was tremendously exciting. The biggest problem was that we are a sample collection mission, and we wanted to collect a large number of very small particles. But we did not want to get hit by a big enough particle to destroy the spacecraft. Plus, comets are surrounded by a coma of gas and dust.
So you have these delicate sort of snowflakes that you're trying to pick up. How do you do that? Well, they use something called aerogel, the least dense solid that we've ever created. I actually have some in my class. My kids get to hold it and pass it around. So I always like to mention that because that was pretty neat how they captured those comet particles and got to study them. Thanks so much for listening.